Hi, this is Rudy Wiedemann, K7RAW, and today I want to talk to you about turning your antenna tuner into a full four-way configurable tuner. Now, we're assuming here that your tuner is a L-match type of a tuner, which is the simplest, most basic, easiest to tune, and most versatile. We're not going to really talk too much about T configuration tuners or pi configuration tuners. The most popular are L configuration tuners. So what is an L configuration? It means that the inductor and capacitor are in some kind of an inverted L orientation. All right? And so what you're seeing in front of you are Smith chart outlines of 8 different configurations, which I want to talk about very briefly, and then zoom into how we're going to do the reconfigurability of your tuner. These first 4, the top 4 here on these charts, these diagrams, are the most common configurations. You'll see that it's a combination of usually one inductor and one capacitor. And if the capacitor is in the series line on top, it's a high pass. If it's in the parallel, then it's a low pass. So this is a low pass. It's an inductor and a capacitor here. All right. And this is also a low pass, inductor and capacitor. But this is where the inductor is after the node that connects the two. This one is the inductors before the load. So similarly, this is a high pass with the capacitor before the node. And here's the capacitor in series after the node. So that's really reconfigurable what we want to achieve. Now, most L-match tuning units will be either fixed as one of these, okay, or will be possibly reconfigurable only in the fact that they could put the capacitor in front of the inductor or after the inductor. And that's it. Sometimes there's a switch, sometimes they're not. But what we're going to show you today is a way with 2 simple switches that you can make it completely reconfigurable to any one of these 4 conditions with the flip of 2 switches into any one of 4 different states, okay, between high, low on each of those 2 switches. Now, for completeness, let's talk for a moment about these 4 configurations. This is where you're using capacitor-capacitor or inductor-inductor, where the capacitor in series is before the node or after the node, as you see here, where the inductor is before the node or the series inductor is after the node. So we're not going to talk about those today unless you really want to rewire your matching unit with those extra components. If you have an inductor, you'll need an extra capacitor and vice versa. So we're really not going to be talking about that because that's not nearly as popular. You can see that it's far more limited. The white area available to actually tune from to get a good match at the center of the Smith chart, this white area here on these 4 conditions is much smaller than the white area available to you to starting point to start from that will allow you with that configuration to tune up and achieve that center Z0 at 50 ohms or whatever is normalized to 50 ohms, right in the center of the Smith chart. That's our sweet spot. And just for review, when we use this kind of configuration, what you'll see is this arc. This is the circle that's coming down with the capacitor so that the parallel capacitor brings you down along an admittance circle, and then the inductor brings you up on an impedance circle to the center, okay? So that's how this works. So the capacitor will always bring you down either on an admittance circle or on an impedance circle, and the inductor will always bring you up either on an impedance circle or on an admittance circle, as you see here. So hopefully I've confused you enough for now. So the idea basically is this, is to be able to allow you much more flexibility and versatility of your tuner with the addition of 2 double pole double throw switches. That's it. And a very simple rewiring that you can actually make your tuner a full 4-way reconfigurable at the flip of 2 switches. So that's what we're going to talk about today. So let's switch gears to the actual layout. Okay, and so let's review what we have here. So what I have is a general purpose T, as in golf T, TEE, type configuration. That's general purpose, that we can use and flip things around and kind of plug in like Legos, okay? So what you see here is this is the input, that's the output, that's our node in the middle, okay? This is ground. This would be the parallel leg. This would be one of the series legs ahead of the node. This would be a series leg after the node, okay? And you just saw what that means in terms of Smith chart tuning. And I have either an L here and a C, L here, or possibly a C here, or a C here and an L here, okay? But it will be an L and a C, or a C and an L, okay? That's why they happen in that particular sequence, C and L, C and L. Okay, so now how do we get to be able to make this either a C and an L, or an L and a C, or this to be a C and an L, or an L and a C, with the other leg in series being connected directly to the input or the output as a short, okay? Because then you'll only have these two components in here. If that series component is after the node, then this would be a short, and vice versa. So how do we do that? Very simple. You use two double pole, double throw switches, okay? And they're ganged together, of course, so if you flip one, they both go for each of these switches. And you connect the center pole here to ground, okay, to that pin, and the upper, when you flip it up, it's an L. If you flip it down, it's a C. And here you wire the upper to the C and to the L. And then you connect that center pin to the center pin of your other double pole, double throw switch to select it to be either an input or an output. And then the other side of that same switch is either an output or an input. And that center connection is then hooked up to your node. So let's just see how this works really quickly. If I flip this in the up position here, okay, then I've got my ground is connected to the L. The bottom of the ground is connected to the bottom of the L here. So I've selected the parallel piece to be a inductor. All right, and also this line gets connected to the capacitor. Now, one thing to note is in all cases, the L and C's are always connected together at the node. So one side of the L or C is always connected together, and we're either flipping the L and C positions this way, or we're flipping the positions this way. So that's really what the two switches do logically. One switch does this, one switch does that. And that's really what it comes down to. So when you wire up your system like this, if you flip up this first switch over here, SW1, then you'll get a high pass filter. The C will be up here. Okay, if you flip this switch up, then that C will be before the node. So it'll be here, not here. So you'll have the C here and the L here. If you flip it down, you'll get low pass. You'll get the C down here, the inductor up here. But with this up, that inductor is still before the node. If you flip this switch down, then that inductor or C, whatever you picked, gets moved over here to the other side after the node. And now you've got a configuration across here. Now, why would we want to do this? Well, it turns out that if our antenna is short, our load resistance is usually less than the source resistance. And that means that the antenna is capacitive, and we need to add some inductance. And that's done usually with a series inductor. Okay? So that means it's a low pass match circuit. And the parallel component is a C. So the low pass will be up here, the inductor will be up here, and this will be a C. Now, the question is, in that case, what's better? Do I have that inductor before the node or after the node? Well, generally, you would select it so that the L and C values would be smallest. If you have one or the other, you'll notice that the L and C values will be quite different between those two situations of before or after the node. And the lower the value, then the less resistance and less loss of efficiency you have in your matching circuit. And that's the other reason why you'd want to flip from before to after or vice versa. In the case of an antenna that's too long, let's say a 20-meter antenna that you want to run on 10 meters, then the load resistance is greater than the source resistance, and that means that you need a capacitor to offset the general inductive, over-inductive, or J is positive, nature of that antenna in the series. So the C would be up here, and the L would be in parallel. And then you decide whether you want the C to be before or after the node with this switch to decide whether you're using components or can use components to do the match that are the lowest values. And they, as you can tell with the previous chart, if you follow that, you'll see that you'll follow different paths on those charts, up the left side or the right side of the Smith chart, around the impedance and the admittance circles on the Smith chart. So there you have it, quick and dirty, of how to turn pretty much any L network antenna matching unit into a full four-way matching unit, and why you might want to do that. So I hope this has been helpful for you folks. If you like it, please click on the like button. And if you like, subscribe to further videos, ring that notification bell. And I hope you get something out of it. And I'd love to see your comments and give me some feedback of what you think. Thanks so much. Bye-bye.